A single typing mistake shut down large parts of the internet. Not a cyber attack, not a power outage. One line of code. On February 28, 2017, an engineer logged into a secure terminal to fix a slow billing system. They typed a standard command to take a small number of servers offline in Northern Virginia. They made a minor mistake. That single error sent an instruction to remove a massive block of servers all at once. The system instantly lost the capacity to operate. The index subsystem, which tracks where every piece of data lives, completely failed. It forced a full system reboot. That reboot took hours. During those hours, the internet didn't collapse completely, but it stopped working the way the world depends on. Smart home devices went dark, corporate networks froze, airline booking systems failed, online stores vanished, bleeding millions of dollars every minute. This wasn't a cyber attack. It wasn't a physical cable snapping under the ocean. It was a normal human error inside a single building, and it exposed something much bigger. The internet doesn't break because of global attacks. It breaks because of local systems failing. Today, the stability of the entire digital world depends on the infrastructure of a single company. How did a bookstore become the system the internet depends on? To answer that question, you have to completely discard the concept of the cloud. The term itself is a marketing invention designed to make the digital world feel weightless and safe. The reality is industrial. The internet is not abstract. It's a physical machine bolted to the ground. When you press a button on your phone, a signal travels through cell towers, fiber optic cables, and backbone lines, physical infrastructure spanning continents and oceans. And eventually, all of it ends up in one place, a data center. These facilities are massive concrete fortresses, hundreds of thousands of servers, millions of components, all running continuously. If the cooling fails, the hardware melts. If the power fails, everything stops. So they build layers of backup, batteries, generators, fuel reserves. Some facilities can run off-grid for days. This level of infrastructure is not optional. It's the cost of keeping the digital world alive. And it creates a problem. Because building this at scale is so expensive, only a handful of companies on Earth can afford to do it. The internet feels decentralized, but physically, it is not. In the early 2000s, Amazon had a problem. Its own infrastructure was breaking under growth. The system was tangled. Amazon was growing faster than its own infrastructure could handle. Engineers were spending more time fixing internal systems than building anything new. The company that was supposed to be disrupting retail was being strangled by its own architecture. Every team depended on every other team. One mistake could take down the entire website. So in 2002, Jeff Bezos made a decision. He forced every team to break their systems apart. No shared databases, no direct access, only communication through APIs. It was brutal, non-negotiable, and it worked. Amazon rebuilt itself as a collection of independent systems. But in doing that, they accidentally built something much bigger, a way to turn computing into a utility. In 2006, they launched AWS Storage Compute Power on demand. Instead of buying servers, companies could rent them. Instead of guessing demand, they could scale instantly. Instead of spending millions up front, they paid only for what they used. It changed everything. Startups exploded, costs dropped, innovation accelerated. And while everyone else saw Amazon as a bookstore, it was quietly becoming something else, the backbone of the internet. AWS solved a fundamental inefficiency. A server used to run one application. Most of the time, it sat idle. AWS changed that. Using a hypervisor, they split one physical machine into many virtual ones. Multiple companies, same hardware, fully isolated, maximum efficiency. Before this, if a company needed a server, they bought a server, a physical machine, sitting in a room, running one application. And if that application only used 10% of the machine's capacity, the other 90% was wasted. Multiply that across every company on Earth, and you get billions of dollars in hardware doing almost nothing. AWS eliminated that waste overnight. Then they added elasticity. When demand spikes, more servers appear. When demand drops, they disappear. Instantly, no waste, no idle capacity. From a business perspective, it's unbeatable. That's why everyone moved. Startups, corporations, governments. In 2013, the CIA signed a $600 million contract with AWS. Think about that. The most secure intelligence agency on Earth decided it was safer to trust a retail company's infrastructure than to build its own. After that, everyone followed. Netflix, NASA, the UK's National Health Service, major banks, news organizations. Companies that would never share office space now share infrastructure. Their data sits on the same physical machines, in the same buildings, cooled by the same systems. They don't think about it. That's the point. Today, AWS controls roughly 30% of global cloud infrastructure. Healthcare systems, financial platforms, logistics, networks, all running on the same underlying system. Human civilization's digital backbone, centralized into a very small number of places. This solved one problem and created another, because now the system is concentrated. When something breaks, it doesn't affect one company, it affects everything. But the real problem is deeper. Once you build on AWS, you don't leave. Your systems adapt to their tools. Your data lives inside their infrastructure. And moving it out? Expensive, slow, risky. Amazon designed it this way, not maliciously, intelligently. Every tool they offer works best with their other tools. Every feature integrates seamlessly inside AWS. But try to move your data to a competitor, and suddenly you're paying egress fees. Fees for taking your own data out of their system. It's like a hotel that charges you to leave. The longer you stay, the more expensive the exit becomes. This is called lock-in, and it gives AWS something powerful: control. Not by force, by structure. If they change pricing, billions shift across the economy. If they fail, entire industries stop. This is no longer just infrastructure, it's leverage. And then there's the physical risk. Northern Virginia, the largest concentration of data centers on Earth, so dense that the region is running out of power. Literally. Utility providers have warned the grid cannot keep up. New data centers are being denied permits. Power companies are delaying connections by years. The physical ground underneath the internet's backbone is reaching its limit, and there is no backup region that can replace it. Not yet. Now think about that. The internet, the system the modern world depends on, is physically constrained by electricity in one region. And that's just one risk. Water shortages, grid failures, cyber attacks. Every layer of the system depends on everything working perfectly, all the time. We didn't design it that way. It evolved that way. The internet was originally designed to survive failure. If one node went down, traffic would reroute. No central point of failure. That was the idea. Today, that idea is gone. We traded decentralization for efficiency, resilience for scale, and it worked. We got instant communication, global platforms, massive innovation. But under the surface, the system became centralized. Quietly, gradually, inevitably. No one voted for it. No one planned it. It just happened. One efficient decision at a time. The 2017 outage wasn't just a bug. It was a glimpse, a reminder that the system we depend on is far more fragile than it looks. Because today, the internet, the system designed to have no single point of failure, now has one. It's on the east coast of the United States. It started as a bookstore, and it runs the world. The question is no longer whether the internet is centralized. We already know it is. The real question is what happens when it fails again. Because next time, it won't just be a glitch. It will be a test of how much of the world was built on something we never fully understood. Subscribe for more stories explaining how the world actually works.